This is the General Electric I-50-S single-phase watt-hour meter. It was built before 1954. I know that since it has a cork gasket on it, according to the American Meter Man's Handbook. This is a 4-dial meter. It's got a rating of 15 amps, but the way that works is it's 15 amps times an overcurrent of 400%, so this is actually what they call a 60 amp service meter. It's generally used on an older house in the 50s. It's a very good meter. The dial on here, I've got the cover off, is actually held magnetically. There's no bearing like the older ones. There's no jewel. It's actually suspended in the air. And I'm running this on 120 volts. You can run these on 120 volts, a lot of these. It has a meter constant of 3.6. What that is that's the number of watt hours per one revolution of this disc. The disc has got 100 tick marks on it, and the leading edge here, I put a little green mark, starts with black. So when that disc revolves one time, it means you've got 3.6 kilowatt or watt hours per revolution. If I turn on the air conditioner this is connected up to here, the disc will start to revolve. It's turning very slow right now because it's only got the fan going. If I go here and try to get it to cool, the air compressor is going to kick in. There it goes. You notice that the disc turned really quick and fast. That's the inrush current on the drew a little bit more power just for a fraction of a second. This particular disc here with this air conditioner revolves once in 15 seconds. And what that does, if it revolves once in 15 seconds, it means that the power consumed is 864 watts. And you can actually calculate that. What you do is you take this off the tripod here. If you take the meter constant of 3.6 watt hours per revolution and you multiply it by 60 minutes in an hour, 60 seconds in a minute, you get a meter constant of 12,960 watt seconds per revolution. Okay, what the heck does that mean? That's a constant for this meter. So you take the 3.6, which is common in an older meter. A lot of the newer ones are 7.2, multiplied by 3,600, which is the number of seconds in an hour, and you get this constant. Now if you divide that by the 15 seconds I just measured for the revolution of the disc, you get 864 watts. And what that is that one revolution of the disc is 12,960 watt seconds for one rev. Divide that by 15, you get 864. This is with an AC that is a fairly new Zenith. It's actually made by OEM by LG. It's a 6,500 BTU an hour air conditioner, and it's supposed to only draw $54 a year. It's got an EER 9.7, which isn't bad. Sometimes you get these as high as 10, 10.8. But I've got this meter hooked up to the air conditioner in line. I've owned this meter for about 25 years, I think, and I use it to go through and measure the power consumption. If I get this thing hooked back on here again. To read this dial, may be fairly obvious that most people do how to read this. You look at the last dial, of course, that reads a 3. This is between a 3 and a 4, so that means that's 33. Then you look at this, it's a little bit closer to the 7 than the 8, so that's 733. This is the more tricky part. Since it already reads 733, this has got to be a 9. Sometimes these dials, there's a lot of friction or wear in them, and it can be to where this might actually be a little bit over in this other side, but because this dial hasn't gone all the way up to the 0 again, you know this is 733 kilowatt hours. Now with a meter like this is a way that I used to keep track of a lot of power consumption, still do. Now there's a lot of little electronic portable ones like the kilowatt version. It's got a different brand like that, but you can go through, and I use those. These are fairly simple and dumb. They tend to be fairly robust for lightning protection and things like that. And anyways, this is the GE I-50-S meter, built before 1954. There's a cork gasket on here. They changed to a Buna rubber gasket in 1954, so this is an older version. I've just got this mounted to a socket, and we were goofing around before the glass broke on it, but I've got about a couple dozen of these meters. I don't sell them, but I've got a lot of these from old swap meets and things like this. Anyways, this disc in here, if you just take your meter, a common today of a newer meter than this, it's what they call a class 200 meters, generally a case of H of 7.2, so the meter constant's higher. Anyways, you take this number, multiply by 3600, and that's the number of watt seconds for 1 rev. You just put that number, you can put it on a label, you just count the number of seconds this dial revolves, and you divide it by, and divide that into the number you calculated with this, and that's the number of watts. It's fairly accurate. I mean, these things are accurate generally within a few percent or even less. If I turn the air conditioner just into fan mode, it's just barely creeping there. And so that's the reason this little dial's on here, in case you want to sit there and go through and not have to silly count for a long time. You can go through and look on here. There's a 220 mark, so you can take your stopwatch and then go through and start timing. When that hits the tick mark like there, look at your stopwatch or watch or whatever, BlackBerry, count the number of seconds to hits the 10 or 20 or whatever, so you get, at least 10 or 15, 20 seconds to get a good estimate. And you can calculate out what the power consumption is. The S on this means it's socketed. This goes into a socket. An A version of this has a set of contacts that are like this on the bottom, where you plug the wires in. Those are even older. You don't see those as often. Anyways, that's the dreaded I-50-S General Electric meter.